Hey class. All right, this is another video on one of the other tougher problems from the Unit 7 lab homework. And this is one on expected value. I think part of the intimidation is just there's so many words and numbers to get through. But the key thing is read it carefully. And really, if you focus on what the question's asking for, and I will show you in the video, hopefully a helpful way to just sort out the information, then it's not nearly as tough as it looks on the surface. So I'm just going to read through it with you and help you pull out the important information, and then I'll talk about how to work it. In the homework, it's actually a two-part question. So you'll have two parts related to it. So this is a similar example. It's not the exact same, but very similar to the one that you'll see. If you bet $2 in a carnival game, you either lose your $2 or gain $4,998. Well, the reason you would gain that is actually the winning prize if you win is worth $5,000. But realize if you have to pay $2 to play, then truly your net winnings would be $5,000 minus the $2 that you paid to play, and that's where they're getting the 4,998 from. Okay, and they just explain it there. Like you're not really going to do anything mathematically to this part. They're just explaining what they did. And it's, like I said, it's very similarly worded on the actual question that you'll see. The game is played by selecting a 3-digit number between 000 and 999. Well, if we really start thinking about that for a second, starting at 000 and then going to 001 and 002 and all the way up till you eventually get to 999, then you need to first realize how many total numbers that is. Well, from 1 to up to 999, that's 999 numbers. So from 1 to 999, that's 999, but plus the 000 possibility means there are 1,000 possible numbers here. Now, of course, if the question that you get on the actual homework says between a 4-digit number, between 0000 and 9999, then you got to realize there's more than 1,000. But you would approach that in a very similar way as I showed here. So what is the probability of winning? Well, you're only going to pick one 3-digit number between those values. And so there's only one winning number, basically, which means your probability of winning is just 1 if you do happen to get the winning number out of 1,000 possible 3-digit numbers that you could pick. And that would be the answer to the first part. The second part is the part that's a little bit more mathematical. If you bet $2 on the number 456, then what's the expected value of your gain or loss? In other words, in the long run, if you played this game, about on average, how much would you expect to either win or lose from paying and then playing this game? That's what we're being asked here. In other words, you're trying to see if it's expected to be a profitable game or not. I think it's probably best here to sort this out by looking at all the possible values and then their probabilities. Well, there's really only 2 possible values because you're only either going to win or lose from playing this game. And if you win, the value is the 4,998 value because that's the $5,000 winning prize minus the $2 that you paid to play. And the probability we said was 1 out of 1,000. If you lose, the value of that is -2 because you paid $2 to play and you're not going to win anything. So that's ultimately a -2 value. The probability of that is all of the leftover. So if the probability of winning was just 1 out of 1,000, then that leaves a remaining 999 numbers that are not the winning number. Okay. And if you sort it out like that, then here's all you've got to do to get your expected value. And I'm just going to put EV for expected value. You take each value and multiply it by its probability. So in a calculator, I would put 4,998, open parentheses, 1 divided by 1,000. but then you add the next combination, which is the -2 times this probability. So plus -2 times the 999 over 1,000, which is the probability of losing. And if you put this straight into a calculator, but make sure you put parentheses and make sure you get the negative sign in front of the 2, then you should be able to get the answer. I'm right now putting this in my calculator. So 4998, open parentheses, 1 divided by 1,000, close parentheses, plus a -2 times 999 divided by 1,000. And of course, I'm also putting that in parentheses. And I am getting $3, positive 3, which means it should be pretty advantageous to actually play this game. In other words, in the long run, if you were to play this game, you might win sometimes and you might lose sometimes. But in the long run, you would be expected to overall have a profit from playing this game. That's not usually the case with carnival games, but I kind of made up the numbers myself. So when you actually do a homework problem, you may not get a positive answer here. You may actually get a negative expected value, which would mean in the long run, if you keep playing this game, you're likely to have an average loss. That's usually the case in casinos and things like that. And if you get a negative, just make sure in the MSL answer box that you click the dash sign on your keyboard for a negative. And so that's it for the expected value problem. And, you know, kind of like the other one that I sent, I hope that just watching this, being a really short video here, that it will be helpful when you get the problem, because like I said, it tends to be one of the tougher ones for the Unit 7 homework or next week when you take the Unit 8 quiz.